Hi and welcome back. So in this video we're going to do problem number 29 out of this first recitation for signals. And this is the last problem of this first recitation. So anyway, what we're supposed to do is match each of the three plots below to one of these functions. And we're given these three functions. So anyway, pretty much the way you do this, you have to eliminate these functions. And you can see that these functions vary in a couple of different ways. This function right here has got an amplitude a little bit bigger than 2. So it's like k, which is a better color. Yeah, this is a better color. It's like k is a little bit, I'll just say it's like approximately equal to 2. It's like there, but it's like a little bit bigger than 2. This one, our k is, I don't know, it's like a little bit less than 4. And then this one too, the k is like a little bit less than 4. In addition, there's a little bit of a phase shift here. These two graphs kind of look similar. B and C look similar, but it's like A is like, looks like it's C flipped across the 0 time axis, right? Or flipped across the time axis. So it's sort of like, you know, there are a few different ways that the graphs vary. They vary in amplitude and they also vary in the shift. However, just by inspection, and we can't necessarily exactly determine this, but it looks like they all have pretty close to the same frequency, pretty close to the same period. And it looks like these are all, like I could represent each of these as one cosine, some amplitude, some omega, some phase shift. So there are a number of ways that these are similar, and really the way we're going to have to solve this is through process of elimination. So the way I'm going to do this is I know that if I have a cosine and a sine, and their omegas are equal, the omega of the sine is equal, or the omega of the cosine is equal to the omega of the sine, then I know that there's a way to rewrite this as some cosine, some k cosine omega t plus phi. I can pretty much factor in how this sine contributes to the cosine and account for it as varying my amplitude and varying my phase shift. But the omegas are the same. The omega, because I have the same omega on this cosine as on the sine, I know that my omegas are going to come out the same here. And for all of these problems, omega is 5. So it makes sense that the omega is always going to be 5. When I'm reducing this down, one of the things that I know is that if I have, say I've got x of t equals a cosine omega t plus b sine omega t, I know from trigonometry that if I want to rewrite this as some k cosine omega t plus phi. And first off, I should say this. I could chug through tons of math, convert these into complex exponentials, and I can figure out exactly, I can do that and figure out exactly what my k and what my phi is going to be, and then figure out what my time shift is and exactly match these functions up. I want to go through this a bit more of an intuitive way. I want to say, right now, I know from trig that if I want to convert my x of t into k cosine omega t plus phi, I know a quick way of figuring out the k using the Pythagorean theorem. I know that k squared is going to be equal to a squared plus b squared. So I know how to figure out my amplitude really quickly. And I can also see that two of these, the first two, are going to have the same amplitude. So it looks like these two have got the same amplitude, or at least that these numbers multiplying my cosine and my sines, those are going to give me my amplitude information. I've got the first two are the same, and I've got, it looks like graphs A and C have got the same amplitude. It looks like they've got the same K, but it looks like graph B has got less of an amplitude, right? And it looks like I've got one thing that's going to give me a smaller amplitude, right? And even if I figure out what the K is for that last problem, here, you know what, I'm even going to, I'm out of paper. Actually, yeah, I'm totally out of paper. Digital paper, I guess. if I want to figure out what the k is for this last function, it's going to be 2 squared plus 2 squared, so 4 plus 4, and then take the square root. So it's going to be root 8, which is equal to 4 times 2, so it's going to be 2 root 2. And if I have 2 root 2, that's going to give me like a little bit, 2 times root 2, that's going to give me a little bit more than 2. So I know that this function, this last function, goes to graph B. That's like the first thing I can figure out. I can figure out by process of elimination, that last function goes to graph B. So now I've got to figure out for these first two, which goes to A and which goes to C. And again, I could, convert these to complex exponentials, and I could chug through a lot of math and figure it out. But I'm going to figure out a bit of a different way. Let's say t is equal to 0. Let's say I want to look at these graphs right when t is equal to 0. So at t is equal to 0, both of these cosines are going, the first one, the cosine is going to be 2. The second one, the cosine is going to be 2. And both of these signs, the signs are going to be 0, right? So at t is equal to 0, I should get 2 on both graph A and graph C. And that's what I get, right? Now let's say t starts growing a little bit. Let's say I add like 0.0001 to that. How does my cosine start changing? Well, my cosine, as soon as t starts growing, my cosine starts going down, right? Like when t is equal to 0, that's like the maximum cosine can ever be. Cosine is equal to 1. So as soon as t starts growing, it's going to start going down. And what's sine going to start doing? The sine is going to start growing, right? If I start subtracting that out, the cosine is going to go down. And if I'm subtracting out sine, as soon as t starts growing a little bit greater than 0, the positive sign will grow. But if I flip the sign here, if I subtract 3 sine 5t, then this is also going to shrink, right? So I started at 2 here, and then as soon as t starts to grow, cosine starts to shrink. And for this first example, sine is also going to shrink as soon as t starts growing a little bit. As soon as I start moving in that direction, for this first function, both my cosine term and my sine term are going to shrink. So therefore, because this function, this a function, I start at 2, and then I start going up, right? I keep increasing. So that doesn't make sense. That means that I can't have this first function the graph of this first function can't be graph A, right? Because as soon as time increases, both my cosine term and my sine term are starting to decrease, right? So I know by process of elimination that this first function is going to have to be graph C, right? Because I start, at time is equal to 0, I start at positive 2, and then as soon as time starts to grow a little bit, I start to decrease, right? Because both my cosine term and my sine term are decreasing. So that first function is function C, and then you could either say by process of elimination, the second function is A, choose a better color, there. The second function is A. You could either do that by process of elimination, or you could say, hey, as soon as at time is equal to 0, both of these functions, this function is equal to 2, this function is equal to 0. As soon as I grow, cosine starts to decrease, and sine, because it's positive here, starts to increase. So it makes sense that I could start at 2 and start going up. It makes sense that I could start increasing as soon as time starts to grow a little bit. So anyway, that is the answer. The answer to this last problem, first equation, the first one, choose a better color. The first function is C, graph C. The second function is graph A. And the third function is graph B. Hopefully that made sense to you. I didn't write a lot of math. Maybe I'll do another video where I do go through a ton of math and actually prove that, yeah, these are the graphs of these 3 functions. But it makes, I think, a little bit more sense to do it intuitively. approach the problem intuitively. So anyway, hopefully this was useful, and I guess I'll see you maybe in the next recitation. Thanks for watching. See you soon.